Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. Hi, I am Saqib Shabir. Today I am going to present my research work with you. We work on multi-level inverter named as 63-level reduced switch asymmetrical cascaded H-bridge multi-level inverter. Now I would like to share my research work with you. Topic of my research paper: 63 level reduced switch asymmetrical cascaded H-bridge multi-level inverter, and the authors are Saqib Hayat, Department of Electrical and Computer Engineering, ComSets, Ahmedabad; Engineer Shehzada Sufyan Sayed, Lecturer, ComSets, Ahmedabad; S. Subhan Sayed, SDO, Peshawar Electric Supply Company; Saqib Shabir, Department of Electrical and Computer Engineering, ComSets, Ahmedabad; Junaid Khan, Department of Electrical and Computer Engineering, ComSets, Ahmedabad. Now I would like to share my research outline with you. First of all, I introduce introduction, engineering problem, engineering solution methodology, block diagram, hardware and software strategy, and the results and conclusion. First of all, I want to introduce my project with you. We designed an inverter which reduce the total harmonic distortions. First of all, I want to introduce inverter. What is inverter? Inverter is a device to convert DC into AC power by switching DC input voltage in a predetermined sequence so as to generate AC voltage. And I would like to introduce multi-level inverter. Multi-level inverters are used to synthesize sinusoidal voltage for several levels of DC voltage. Multiple levels are used to reduce THDs and total harmonic distortions. What is the engineering problem? Increased number of harmonics, higher switching losses due to high switching frequency, switching device bear high voltage and current stress. The methodology we choose to implement our project is overall improved number of harmonics, increase efficiency of the system, less conduction and switching losses, eliminate the need of filter, compact circuitry topology. The results are achieved through technique in which DC offsets are taken as a carrier and absolute value of sine wave as a reference. And this is the block diagram. First, we make a control circuit, in which we used a technique, phase disposition pulse width modulation, and this whole circuit is also implemented on a single microcontroller or and by using Arduino through coding, and switching sequence circuit through DC offsets and H-bridge and load. This is the mathematical model of our project, how we define different voltage level values. We use Fourier analysis. By using this equation, we define different voltage levels for 50 Hz frequency. These are the different levels of voltage. V1 for first level, for third level, for fifth, seventh, 9 and 11 and so on. These are the method how to we calculate. Through this method and through this equation we calculate THDs, total harmonic distortion. By using this equation for first 27 harmonics, we calculate TED 1.004%. And this is the model for which we used to design our research and our project. We used total 9 number of switches. 4 switches are used in H-bridge. Basically, H-bridge is used to convert DC into AC. by triggering the gate pulse, and these are the these switches are used to trigger the gate of H-bridge switches. And this is the brain of our this whole project, and these are the different levels of switching, and through which we trigger different which we give the gate pulse of to the MOSFET. And this is the different levels: theta 1, theta 2, theta 3. These are the switching angles through which the different gates are trigger. MOSFET gates are triggered. Basically, gate is very important part of the MOSFET. If gate is triggered, then MOSFET is working, otherwise it did not work. And this is the amplitude and time amplitude graph, and this is the output voltage, and this is nearly equal to the pure sinusoidal wave with a less number of harmonic distortions. And through our result, and the simulation based result is 1.02% THDs. And these are the this is the power, RMS current and RMS voltage. Conclusion: we reduce THDs to 1.02%. Reduction of THD results in better efficiency. Phase disposition pulse modulation in all pulse width modulation technique gives smaller number of THDs as output. Now I would like to share the work or the model which we designed for this purpose. Let me show you this one. Okay, this is the project we designed. We designed this project on MATLAB Simulink by using Simulink software, and this is the brain of the switches. And these all work is implemented through code on Arduino or by using microcontroller. These are the simple, we use different switching levels. This is not a big deal, it's very simple by using coding. And these are the 5 switches are used to trigger these 4 H-bridge MOSFETs to convert DC into AC. And this is very economical and efficient design of multi-level inverter with less number of TDs. I hope you like our project, and we also explain our research work in research paper already submitted to the conference. Due to coronavirus, we are not able to present our project physically. Thank you so much for listening to me.